Hello and welcome to this MultiversX presentation on building a dApp from scratch. My name is Tudor Moral and I will be guiding you through the process of creating a Vite React app and wiring it up to the MultiversX ecosystem packages that will allow us to interact with a smart contract. So, without further ado, let's get started. We're going to our terminal. We're going to create a new Vite app, giving it a project name called Build a dApp from Scratch. We're going to choose the React template, and then we're going to choose the TypeScript and SWC template. And next, we're going to move to our editor. Here we are in our editor. You can see the project here. We can see the README. And what we're going to do is we're going to open the terminal again. And we see the commands in package.json. And of course, they're not working because we haven't installed our dependencies. Once the dependencies have been installed, we can run yarn dev. And let's see how our app looks in the browser. Here it is. We have a running app with a counter. And now we're going to add the MultiversX specific packages. And the first one is the SDK core. We are going to use version 12.9.8. We're going to use fixed versions. The next one is the SDK dApp, version 21. And the last one is going to be the MultiversX SDK network providers. For this one, we're going to use, again, version 2. Let's run again yarn to install these. Once they are done installing, let's go ahead in app.tsx, delete the default content, and start creating our own content. We're going to delete this piece of state, only keep the CSS, and we're gonna start with the dApp provider. We're gonna specify the environment, which is gonna be the DevNet, and let's just see if the dApp runs by adding a simple text inside. We're gonna start the browser, and it doesn't run for the moment. Let's see why. It's because we are missing some polyfills. So we're gonna have to tweak the Vite config a bit to allow us to use these polyfills. And what we're gonna do is we're gonna install some packages in dev mode. First one is the Vite plugin polyfills, node polyfills. Let's import them here. So we're gonna import from Vite plugin node polyfills the node polyfills object and run it here in plugins. You shouldn't forget to add a global true as an option there. Let's check again, and our dApp is running. Let's continue setting up our environment. We see we have the DevNet environment. We're gonna create any config folder, and then in our folder we're gonna have specific configs. The first one is gonna be the config for DevNet, and we're simply gonna specify the environment here by using the environments enum from SDK dev types. And next one is the mainnet config. This will have the main environments enum. The next thing that we're gonna do is we're gonna create specific configs in package.json to be run depending on whether we want to use one config or the other one. And we're going to create some script that copy the specific configs into an index file, and then this index file will be referenced across the project and will be ignored in git ignore. So for example, when you run start devnet, the project will immediately copy the devnet config and then run yarn start. The same thing goes for mainnet. So we're configuring here to run the mainnet config, and they have equivalent commands for building, that is build devnet and build mainnet. Of course, you could have a different strategy by using environment files, but we recommend you to use this option in the tutorial. Let's test it by running build devnet. We can see that the command is successful, and of course we can already import the environment from the config here. Let's go run yarn start devnet, see if our app is still running, and yes, the app is still running. Let's see if we can import variables directly from folders, and we can see that for now this doesn't work, and this is because we cannot use absolute imports. So let's tweak our tsconfig a bit by adding a new development package called Vite tsconfig pass, and then enter our Vite config file and use the default object exposed from Vite tsconfig paths, which then we're gonna add at the end of our plugins. Let's check again, and we see that we can import directly from config index. And of course, let's try to run our application and see if it still works. Let's go to Chrome, and yeah, our app is still working. Next, let's set up our routes. Let's install React Router DOM. It's installed. We are in our app.tsx file. We're going to import the browser router from React Router DOM, and we're going to insert the router inside our dApp provider and create our first routes. The first one is going to lead to /. It's going to be our main route, and it's going to point to the home page. And then, of course, we need an unlock page pointing to unlock and referencing the unlock page component. For this, let's create a pages folder and create these two components, the home page first and the unlock page. For now, just a simple copy of the home page, and then reference them here from the pages folder by using an absolute import. Check again if our app is still running, and here we have our home page and our unlock page. So here we are creating folders for the home page and for the unlock page. Inside the home page folder, we'll create another folder called components, and inside this components folder, we want to create a balance section where we will show the user's balance by making use of a component from SDK dApp called format amount, which accepts the account's balance and the EGLD label. It has other properties, but for now I'll just make use of these two. And to get the account's balance, we have to use a hook called useGetAccountInfo and use getNetworkConfig to get the current network. Once we are done creating this component, we can go ahead and import it in the homepage, and we will create some conditional logic based on the isLoggedIn flag that says if the user is logged in, show him the balance section and the logout button, and if the user is not logged in, then have a button that leads the user to the unlock page. The logout button will use a helper called logout from SDK dApp. And at the end, we still want to check if our app is still working. So let's run yarn start.net, go to Chrome, and we can see that we can navigate to the unlock page. Let's do the same for the unlock page. Create a new directory called unlock page and add here all the different ways to log in with all the supported providers. First one will be the extension login button, which will log in with the DeFi wallet. All of them support the same props, but will make a slight difference by using for the extension login button the onLogin redirect prop, while the others will have the same props. And we know that except the web wallet, all the other providers are local providers, so they won't navigate away from your page. That's why you could use the onLogin redirect for all of them except the web wallet login button. We'll put the correct labels for each one of them and then check if our login is working. Click connect, click the DeFi wallet, choose an address, and we see that we were able to log in. Let's now try to log in with X Portal, that is with Wallet Connect, see if it works. We're going to run yarn start devnet, open Chrome, and no, it doesn't work. And this is because we don't have Wallet Connect project ID. So the way we're gonna provide this project ID is by specifying a custom network config. The name can be whatever. Then here we need to specify this parameter called Wallet Connect v2 project ID. And for that, let's create a base config that will always be exported from our specific configs and have it defined here. For now, we don't have such a project ID, but we'll soon get one. And to do that, we could go to Cloud Wallet Connect and obtain this project ID. So in our case, this will be our v2 project ID. So let's re-export everything from base config. We do this for mainnet also, and we won't be able to find it here since we should also export it from index. Here it is. It was copied by build devnet. So let's try it now to see if it works. We refresh the page. We are having some errors. We need to remove strict mode, but this will be fixed in a later version of SDK dApp. And our login will be working from now on. Let's make the necessary preparations to interact with the contract. For this, we'll need to add the contract address in each of our configs, and we need to create a new folder called ABIs and to paste the contract's ABI here. In our case, it will be an escrow contract that will allow you to do certain actions like proposals, canceling, accepting. Up next, what we are going to do is create a utils folder with a smart contract in it, and we are going to use some methods exposed by SDK core. First, an ABI that reads with the ABI registry from the JSON from our ABIs folder, and then the smart contract with the new smart contract class. Okay, we are done with this. When you compile a contract, you're provided with two resulting files. The first is the WASM file, which is the compiled code version stored on the blockchain. The second is the ABI file, which stands for Application Binary Interface. This ABI file is a JSON document detailing the behavior of the smart contract. Within it, you can find details like the commit hash, the Rust version, and the version of the framework used. Crucially, the ABI also showcases a list of endpoints the smart contract offers. For each endpoint, the name is provided, an indication if it's mutable, signifying it can be triggered by a transaction, and whether it accepts payments. Additionally, the expected input arguments and the potential output arguments for each endpoint are also specified. In this scenario, we are discussing the NFT escrow smart contract has an endpoint named escrow. This endpoint receives the NFT you provide as well as details of the desired NFT, like nonce and the targeted address you expect will compile the offer. When this is initiated, an offer ID is created. This offer ID can be used to either cancel the order by its creator or for the targeted address to accept the offer, subsequently sending the anticipated NFT. Endpoints that are solely for a reading are termed views. They allow users to query the smart contract for information. For instance, an individual can retrieve offers they've made by entering their address, which will give a list of pairs consisting of offer ID and offer. Similarly, there is a method for accessing offers that an address can agree to. The ABI also defines custom types such as structs. These are essential for decoding the data that is retrieved. Now that we have gone through what the escrow contract does, let's create a page which allows us to easily deploy the contract. And we're simply going to call it deployment page. We're going to create a component inside it and create a directory called components with another component where we can specify the contract or deployment address, which will be followed by a form that will allow us to deploy the contract. And it will have several inputs. The first one will be file type input, a contract address that will be only used if we want to upgrade the contract. And let's format here the code a bit. Let's create a submit button and an upgrade button. And then in the end, we will add a text area that contains the WASM code. Let's continue with our deployment page by inserting the deployed contract form component. And now we know that we're missing our contract deployer address. And for that, we want to create a hook which fetches the contract details. We're going to call it useGetContract or deployer address. And in it, we will do some custom logic that will first check if the user is logged in. It will get the network config. It will use the useGetSuccessfulTransactions from SDK dApp, and then we'll create a function called fetchContractAddress based on the user's address, which will perform some custom logic and return the contract address in the end. And then another one, which will be called getContractAddress after deploy, which will be run conditionally by an effect, which is looking into a session ID. We'll now create a second hook called useDeployment. We need to create some types for it. Then we are going back to the hook and creating this function called deploy, which takes the arguments for the smart contract metadata. And in the end, it's calling the new smart contract constructor and it's calling the deploy method on the smart contract. the address of the user logging in will be the one that is deploying the contract. Let's continue by configuring the send transaction function, which will be called at the end. We want to first refresh the account to make sure we have the latest nonce from the API. We are filling in the information for our toast that will track the transaction, and here we are sending our transaction. Make sure we have the code wrapped in dry catch, and at the end of the hook we will be returning two functions. One will be the upgrade function and the other one will be the deploy function. They are similar, the only difference being that we specify the address. If you want to upgrade the contract, then we call smart contract upgrade and smart contract deploy, depending on the action that we're doing. And of course, in the end, we are binding these actions to our new form. Let's now connect our deploy contract form to the two actions, the deploy action and the update action. We will create a session ID, and this session ID will be fetched from SDK dApp as soon as a transaction was sent. We are creating now two handlers here and passing the two handlers to the form. Let's pass the session ID here, of course, as an object, so that it may fetch the contract address correctly based on the transaction that was found inside this session ID. We create a placeholder for the WASM code and a hook called use upload WASM code. We'll just paste the contents here and then get our WASM code from this hook. Of course, you can find all the files inside the repo. Not forget to call to string there. We'll use Axios as our fetch library. We'll install it and let's run our application. We need to include our deploy page inside our routes. And there it is, our deploy page is live. The time has come for us to actually try to deploy our contract. We're going to start our project. We're going to the deployment page, choosing the WASM file and pressing deploy. We're signing the transaction with a DeFi wallet and waiting for the transaction to complete. And successfully, we've got our contract address. We are filling it in our config. And then let's try an upgrade. We are filling in the contract address, again, the WASM file, confirming the transaction, and in the end, we are getting our address that has upgraded the contract. So up next, we are going to prepare the different methods specific to React. Namely, we are going to create some hooks for each of the actions that the contract allows us to do. The first one will be the use create offer transaction, and for now, we are just going to create them as placeholders. The next one will be create a cancel transaction for an offer and create accept transactions. Let's go ahead and create the actual transactions that we are going to use. And for that, we start with cancel transaction, get the account by using the use get account info. Look here at the parameters. We've seen that it accepts a offer ID. And at the end, we're going to expose a function from this hook, give it a parameter, and then make sure we pass everything that is needed, like the chain ID, the address, and at the end call to plain object to get the actual transaction. And at the end, we are going to expose the function. Next, we are going to go to create confirm transaction, make a small renaming there, and have the same approach, have it return a function. Let's see here. Again, it accepts a buffer ID, and we are going to return a smart contract and call the methods, then accept, pass it the offer ID. Here we are going to pass the amount. We are going to use the token transfer utility for non-fungible. And there we have two commas. We're going to have to remove one of them. And here we are accepting more arguments, the collection ID and the nonce. And again, pass the gas limit, chain ID, and the address. Return the function at the end. Let's finish up our transactions by editing the create offer transaction. We're going to expose function, but first let's look in the ABI to see what arguments it wants. For now, there are three arguments: wanted collection ID, wanted nonce, and wanted address. We're calling the smart contract object's methods with the escrow member, we're going to pass these 3 parameters there, and we need to identify the collection, the NFTs collection. And for that, we need the collection ID and the nonce. So we need to make sure we are adding these arguments to the function and using them. Okay, this would be about it. Make sure we are calling the chain ID, and we're almost done. We're returning the function at the end. Now that we have created these transactions, let's look a bit at what we are missing here in the ABI, and let's look at the outputs. We see the offer output and we see the types here. So what we want to do is create a types folder and create response types for our transactions. And the first one that we are going to create is the offer response type. And we are going to add here each response type based on the ABI. Some of them are big numbers. That's why we need to install the big number library. And the addresses will be address object exposed by SDK core. And we will do the same for the offer type. Let's move all of our current transactions in a folder called transactions and create another folder for queries, since the contract allows us to interrogate its status, and we will prepare a hook for this called use created offers and implement it later. Let's do the same for use created offers. This one will be a bit more complex, and we will create the same function, get created offers, just that in the end this function will be run by an effect. We need to first create a network provider, and we'll later see how to use it. We can instantiate it only once after the hook is called. Let's check how should we use this interaction. We see here that we need to pass the account address, and then we are creating a query with the interaction build query, and we have to parse the response. Parsing the response will be a bit more complicated, but you will have access to the code and you will be able to use it as shown here. We need to parse all the response types that come from the contract. And this is the way to do it. We are setting the state by set created offers with offers response. And we're just logging them to see that the response is correct. And at the end, we're going to call this in effect based on the account address. And at the end, return everything. We are going to do the same for use wanted offers. We are going to first create a piece of state and then a method that we are going to wrap in a use callback. We have to bring again the network provider here, then create the interaction. We pass in the account address as argument to the callback, create the query, and then parse the response. If we have data, we're going to interpret this data. We make sure all of our dependencies are imported and make sure to save it to this piece of state and log it here to see if it's computed correctly. Again, wrap this in an effect based on the account address, and in the end, return the data. Let's now use the transactions that we have created by creating a new offer page with a create offer page component. It's just a mockup for now. We need to link it to a root, and let's return here. And we'll want to create a form for this offer page. For this, we'll use the forming library, but of course, you're free to use whatever library you prefer. And then, of course, add forming with yarn and add UP validation. Now for each property that Formic accepts, we need to create a hook that exposes this property. And let's create our use create offer form hook. And the purpose of this hook will be to serve the create offer page form with all the information it needs. So we'll start with the initial values. We have the type here. We'll just fill it in with some initial data and then create a validation schema for each of the data that will be filled in by the user. Make a typed schema by creating create offer schema object type. And let's not forget to create our onSubmit function that will be wrapped in a callback. It will accept the same values as forming, and it will call the get offer transaction function exposed by our previous hooks. Let's make sure we import the use create offer transaction hook and then call here the function that was exposed. And then we are just going to call the send transaction helper from SDK dApp and add all the necessary parameters here, main one being the transaction, and then some messages that we want to have included in the toast and we don't want to be redirected anywhere after signing. So once the transaction is sent to be signed, it will also be sent to the blockchain. So at the end, we return all the necessary values. We forgot to give it the right name and just have the values here. What's missing from our form is the actual body of the form. We're simply gonna paste it here, but we need to make sure that all the components are being imported from forming, and it's also important that all the names are matching with our type definition. Okay. We need to link the submit function. It will be called there. Seems okay. Let's now make use of our create offer page. We're going to start the project. We're going to log in by using the DeFi wallet. Okay, we are logged in. And let's see what NFTs we've got. We're gonna pick one, fill in the collection, then we're gonna fill in the nouns. And the next one, same thing. Let's pick a different wallet address and submit. It's not working because we don't have two mandatory components. The send transaction model is actually mandatory for sending, but the transaction toast list help us track the transactions after sending them, and we need to add them above the roots in order for them to work. And let's go again through the same process of filling in the form, fill in the address and submit. We can sign it, and let's check the transaction in Explorer. We see it was sent, and we just have to wait for it to execute. We see it's the same NFT we have filled in. We can inspect the data. Everything seems okay. Refresh the page if necessary, and it's success. We managed to send our first transaction. Let's now go ahead and create a component that interrogates the contract, namely the created offer section. And for this, we're going to use the hook that we just created, the use created offers hook, and we want to render the created offers inside the table. We will add a little bit of styling to this component. We're just gonna paste it here. We will add the title, created offers, a link that will go to the create page. You could also use the link component, and let's add the table below, and we're just gonna map through the created offers and not forget to close the div and include this component. And here it is. We can inspect the offers here. And you remember we left there a log, which allows us to see the offers in the console and to add different elements. Okay, now a similar component, wanted offers, with the accept button. Let's edit here, wanted offers. Here it is, our wanted offer section. Since our buttons for accepting and canceling a transaction are just labels for now, let's go ahead and create the actual transactions for them. And the first one would be the cancel offer transaction, which accepts an offer ID, and at the end we'll again call send transaction with the necessary flags for the toast element, and it will be called here. We're gonna get the action and pass it on to the button on click handler. Let's do the same. Let's create the accept offer function, call send transaction, expose it, and call it when the user clicks the button. And pass all the necessary parameters. Let's check it here. We have canceled. It opens the DeFi wallet. The transaction was sent. Yep, there it is. It was executed with success. Let's check the accept action. It's okay. It opens the DeFi wallet. The transaction gets sent. It's done. The accept transaction has worked also. Congrats! We've reached the end of our tutorial and we've learned how to build a dApp from scratch. Let's do a small recap of what we've learned. In the first part, we've learned to create a React project with a Vice setup. Then we've installed the prerequisites. Then we've set up the dApp environment. Then the roots. We've managed to log in and log out in our dApp. Then we looked into VM queries and transactions. We've looked into signing and sending transactions. And at the end, we've learned to deploy a smart contract from the UI. Don't forget to check out the tutorial's public repo, which is called MX NFT escrow dApp. and of course the SDK dApp repo and the template dApp, which will help you bootstrap your dApps easier on the MultiversX blockchain. Thank you and have fun building.